Hi, welcome once again to another lesson with Domoji Math and Science. In today's lesson, we'll be looking at sine rule and its application. We will see how to apply sine rule in triangles that are not 90 degrees. That means that are not right-angled triangle. An example is this that we have here, triangle ABC. We will find the angles of A and C of this triangle. But before we get into that, I want to explain the concept of sine rule properly. Let's get started. For a regular right angle triangle, if we have a right angle triangle, easily, if I have my right angle triangle and I'm looking for any angle in this angle, I can use SOHCAHTOA as explained in our previous lesson. But now we'll look at a case. Today we'll be looking at cases where SOHCAHTOA is not applicable, where we don't have a right angle triangle. Now we'll be using the sine rule. Now let's look at this triangle. If you have a triangle this way, if you have a triangle like this, and this is triangle A, B, and C. Now, if I have a line here that divides this line, this angle symmetrically, and that divides this line BC into two equal parts symmetrically and forms a right-angled triangle, this height, let's call it H. Now, to properly label this triangle, if the angle at this point is A, we'll say that this line is called small a. If the angle at this point is big B, we say this line is called small b. If the angle at this side is big C, we call this our what? Our small c. Now remember from our SOHCAHTOA that if I have an angle B here, for my angle B, the sine of this angle B, the big B, is equals to opposite over hypotenuse. That will be the H here, that will be H over small c. And for my, if sine B is equals to H over small c, that implies that H itself is equals to C, you cross multiply, times sine B. The same thing applies if you now take the angle at what? At C. If I now consider the angle at C, you agree with me that if I'm considering the angle at C, sine of C will be equals to opposite, which is still this H, over hypotenuse. That will be equals to H over small b. Now cross multiply again, we'll have that H is equals to B sine C. Now if H is equals to B sine C and the same H is equals to C sine B, obviously I can come to say that C sine B is equals to B sine C. Now if this is, then let's divide. If you divide this side by sine B, you divide this side also by what? By sine B. This cancels this. So my C is equals to B sine C over sine B. Now divide this side also by sine C. Then you come and divide this side also by what? By sine C. So this sine C here will cancel sine C here. Then I can conclude that C over sine C is equals to B over sine B. Now, if I do the same thing I've done to this angle, I pick a line from here. I bring it symmetrical to this point. And this is a right angle triangle. This is a right angle triangle. If I do the same thing, you follow the same process, you come to understand that my C and my A will give me A over sine A to be equals to C over sine C. I advise you give this a try, give it a try, and please do comment, give me your results in the comment section. If you have any challenge, kindly let me know in the comment section and I'll be there to help you out. Now, but if, let's call this our equation 1 and let's call this equation 2. So if sine C over sine C is equals to B over sine B, and the same C over sine C is still equals to A over sine A, we can obviously conclude that A over sine A is equals to B over sine B and is equals to C over sine C. With this understanding, we can now apply this in our question that we have for today. Let's get back to today's question. Thank you. Now, for this question, we have this triangle showing that B, the angle at B is 1, 1, 115.6, and we are to look for the angle at B, the angle at C, sorry, and the angle at A. Knowing that C over sine C is equals to B over sine B and is equals to A over sine A. Here I have the angle at B, then I can talk of sine B, and I have this side which is my B, the opposite side to A, this is my A, and this is my C. Since I have this side of the question and I have this side of the question, I have B and I have A, and I have the angle at B, we can pick B over sine B to be equals to A over what? Sine A. Now, my B is 14.35 over sine B. Sine B, that's the sine of 115.6 is equals to A, which is 7.82 over sine A. So that if you now cross multiply both sides, you should come up with 7.82 sine 115.6 all over 14.35 to be equals to sine A. Now, if you had followed us when we dealt with quadrants, with trigonometric quadrants, you know that our sine of 115.6 is the same thing as 180 minus 115.6. That's equals to sine of 64.4. And in this angle, 115.6 falls in the second quadrant, and this angle is positive in the second quadrant. In the description below, we'll put a link to our lesson on trigonometric quadrants. Now, sine 115.6 is the same thing as 115.6, is the same thing as 0. That means this is 7.82 times sine 115.6, that's 0.9018 over 14.35 is equals to sine A. So that if you multiply it out, that will be times 7.82 is equals to, that becomes 7.052 over 14.35 to be equals to sine A. So that sine A now is equals to 7.052 divided by 14.35. That's equals to 0.4915. Now, if sine A is equals to 0.4195, A obviously is equals to the arc sine. That's the arc sine of 0.4915. Now, the arc sine of 0.4915 should be the same thing as, 29.44 degrees. That's 29.44 degrees. That's 29.4 degrees. We can leave it at 29.4 degrees. Now we have gotten our A. I think it's time we begin to look for our angle at C. We've gotten. Now for the angle at C. Now from this triangle, we have that the angle at A here is given as 29.4, and we have the angle at B as 115.6. Now if we sum up the angles in the triangle, the angle at C plus the angle at B plus the angle at A should sum up to 180 degrees. That's angle in a triangle. Angle in a triangle. So the angle at C, that's angle at C plus 115.6 plus 29.4 is equals to 180 degrees. So that the angle at C now plus 115.6 plus 29.4, that's 29.4 plus 115.6, permit me, I'm punching my calculator, that's 145 degrees is equals to 180 degrees. So that the angle at C now is equals to 180 minus 145 degrees, which is equals to 180 minus 145 degrees, that's 35 degrees. That's equals to 35 degrees. So now we've fully defined the triangle. Already we have the angle at A to be equals to 29.4, and we have the angle at C to be equals to 35 degrees.